Good morning, everyone. We're just gonna wait a minute or so for people to trickle in from the waiting room, and then we'll get started. Hey, welcome. Happy to have you joining us today to learn about how roadway design can impact bicyclist and pedestrian safety. So today's workshop module is part of a 5-part training for a Watch for Me NC program. So some of this materials previously presented a law enforcement and full trainings or part-day refresher courses, but this year we're making the materials available to everyone in the Watch for Me partner communities. So I'm Stephen Heine with Watch for Me NC program, which is supported through a grant from the Governor's Highway Safety Program. I'm a research associate here at the Highway Safety Research Center at UNC. We'll be getting into the materials soon, but we just have a few housekeeping items to review first. So first, we're on Zoom, as you can see, and I encourage you to share your camera if you're able. It helps us to kind of see your reactions, see your faces, know that there's some people out there. However, we do ask that you mute yourself if you're not asking questions during the presentation. And do want to let you know, you probably already saw the alert, that this session is being recorded and it will be available for others to review after we conclude. So if you're having any problems with audio or connectivity, just want to let you know there's a few things you can try. Number one, you can call into the phone line instead of using a computer audio. That maybe helps free up a little bit of bandwidth. You could also, although I just told you to turn your camera on, you could try turning your video camera off if that saves some of your bandwidth. Another option is just trying to exit and re-enter the Zoom, and we'll let you right in from the waiting room that way. If you are having any technical issues, Kristen Blank is standing by, so feel free to chat directly to her, and she can help you try to troubleshoot any of those through the chat. And as we go along, if you have any questions about this, do feel free. So Kristen Blank, as well as Sarah O'Brien, who are both with the Watch for Me NC program, and both my colleagues at the Highway Safety Research Center are on the chat. So they're happy to answer questions as we go along as well. So just a quick reminder of why we're here and just a little bit about the Watch for Me NC program. So the main goal of the program is to reduce pedestrian bicycle injuries and deaths. And we do so through a comprehensive targeted approach of public education, community engagement, and leveraging specific law enforcement events. So this year we've welcomed 18 communities to the Watch for Me program. We have 15 returning partners, and then we have 3 partners that are brand new this year. So we're offering multiple opportunities to participate and learn more about ways to improve bicyclist and pedestrian safety in your community. So this workshop is the 3rd module in a series of 5. The workshops provide an opportunity for all community members to learn more about pedestrian bicyclist safety, and that way to help bolster their knowledge and inform community participation in the Watch for Me program. You don't need to write all these down, but so you should have received calendar invites to these meetings as a Watch for Me partner. If you haven't, you feel free to reach out to Kristen, who's on the chat, and she can help to get those to you. They're also available on the Watch for Me NC website. But as a reminder, a law enforcement officer from your community is required to attend 3 out of the 5 trainings, with module 1 or 2 being one of them. Today's module is available for all community members, and including the law enforcement officers. And if you missed any of the earlier modules and did not receive information on how to access those, we do have the recordings available. So again, you can reach out to Kristen, and she can help direct you towards those recordings. So if you're thinking about how any of the other modules might be relevant to your community, quickly introduce you to what's upcoming after this one. So module 4, which will be in August, is on crash data investigation and reporting. It's highly recommended as another module for law enforcement to attend, but it it's information that could be helpful for all Watch for Me partner agencies. In this module, we'll go through some common bicycle and pedestrian crash patterns or types, how you can use the crash data to understand key behaviors, locations, or times and seasons to focus ways to drive down crashes, and considerations when investigating bicycle or pedestrian crashes specifically, and why reporting details when filling out the DMV 349 are critical with these types of crashes. And then our final module, module 5 in September, will be on communications around pedestrian bicycle safety. And that'll focus on communication efforts, NCDOT's media plans, and we'll have some discussion on how to frame just discussing crashes and pedestrian bicycle safety when talking to the media. And we'll also share a communications toolkit resource and some effective language in discussing ped bike safety. So once you've met eligibility criteria by officers participating in at least 3 of the modules, your attendance will be reported to GHSP, and your law enforcement agency will have access to the statewide traffic enforcement program reporting system, so you can report on your eligible Watch for Me activities. And your community also will be eligible to receive Watch for Me education materials. So with that, we'll get into today's topic. The main objectives of today's workshop, number 1 is to understand the link between design and safety between people walking and biking. Number 2, identify what situations you can use design to help mitigate those safety issues. And then we'll go through quite a few common treatments that are used to improve safety for bicyclists and pedestrians, and how they actually work to mitigate safety. So a brief agenda, we'll do, we already did a little bit of an introduction to Watch for Me NC. We'll talk about road design and how it fits into the safe system approach. A little information on why road design matters when it comes to safety, and how design actually impacts safety. And then we'll look at, again, the countermeasures for pedestrian and bicycle safety. And we'll end with a quick little discussion on policy and how it relates to planning for safety in your communities. So another reminder, feel free to use the chat box along the way. Like I said, we have a couple of people standing by to answer questions. If they can answer them right away, they'll be there in the chat box. Otherwise, if we have some larger questions at the end of the presentation, we'll have time, so you can either send your questions through chat, or we'll be able to just have a quick discussion. You can come off mic. So for those of you not familiar with the Watch for Me NC program, we at the Highway Safety Research Center support local agencies in raising awareness of the issues within your respective agencies, organizations, and communities through partnership development and outreach, with this overall goal of preventing pedestrian and bicyclist injuries and deaths by creating a culture of safety. So in sort of looking at these short-term to longer-term goals, the thought for this session is where does design fit among these goals? So today we'll be looking at how the design of our roadways in many ways determines the behavior of users and can encourage either safe or unsafe behaviors. We'll look at how design fits with other strategies like enforcement and education, and how those responsible for enforcement with an understanding of design that we look at today could recommend some changes to the environment where they see that you can't just keep enforcing to try to get people to slow down or behave in a safe manner. And this all really feeds into that culture of safety across disciplines, and both in the community and in those who are designing the roadways or responsible for enforcement, or those out there trying to educate the public on safer behaviors. So this is sort of a common model that we see when we're talking about, thinking about the whole system and how we actually address some of these safety problems. So really, when we're thinking about transformative change, we want to push below that surface there. So rather than looking at events and just a reaction to the problem, we want to think more deeply about what causes these crash events and start to explore the underlying structures, the beliefs and values that inform some of these patterns and trends that we see in communities. Crash data alone doesn't give us this full picture. It does help to going below the surface to understand these trends. So much of what we'll focus on today is trying to understand how our existing transportation network, and specifically design of the roadways, can influence the likelihood of a crash occurring, and to really think about the relationship between the roadway design and how people behave based on the cues they get from that design. So a lot of this in looking at underlying structures is starting to recognize and acknowledge that many crash hotspots are not just the reflection of behavior at the time, but really a reflection of a long history of how we designed our cities, how we valued cars and drivers' convenience of moving through them over the people walking and bicycling within them. And that history, is reflected in how our streets look, how we've allocated space on those streets to different modes, and what access looks like for people on different modes. You know, and we can see this based on a couple of examples. So if you look on the left, it's thinking about the evolution of transportation and land use planning, where distance has led to higher speeds, and it's also led to cutting off networks and access. So, increasing those highways through the middle of cities so that people can speed to farther away places, but also limiting, the ability to walk across those areas as well. And another consideration is thinking about the development and regulation of vehicles and how that's changed over time. And primarily that's been to the benefit of those inside the vehicles, and often that's at the detriment of anyone outside of the vehicle, thinking of vehicle size, the ability for vehicles to go faster and faster, height, and the visibility of those driving the vehicles. We also need to understand that not everyone chooses to drive. Not everyone has access to a motor vehicle. We have children, older people who can no longer drive, people with a disability, and people who cannot afford a car are often at a disadvantage with the way that our transportation network is designed. So if you look at the picture here, you have a transit stop, you have a school, you have places where people may need to walk to, but there's not only just a lack of facilities too, there's a lack of crossing opportunities, and there's cues that people to get from the road. So we'll talk more about how design provides cues, but this road provides cues to the driver that there's not going to be people present, that it's a fine place to speed through, to take a sort of quick left-hand turn without looking for pedestrians. So when we're thinking about those underlying structures, we're thinking about who's been considered in designing the roadways, and who not only does not choose to drive, but doesn't have access to a vehicle in order to drive, and is often forgot about when we design the roadways. So these are just a few examples that show the inequities within the transportation system and in relation to people walking and biking. So it's important to think about and acknowledge that responsibility for road safety is not equally shared. For instance, research shows that people of color are disproportionately represented in fatal crashes involving people walking. This example of disparity falls along race and ethnicity as shown on the slide, but it can also be related to gender, age, disability status, and income. And much of this is a legacy impact of where high-speed streets have been located and where there's been a lack of investment in infrastructure. It's important to share these thoughts today on equity before our session, because it offers a little bit of context about the road safety system and the persisting inequities within this system. So just as we've discussed state laws in previous modules, thinking about how one's community has developed over time should also be considered when thinking about inequities. And that's thinking about where this design has failed, who has a say in what their community looks like, and how people can access everyday needs within it. So our focus on design in this module is going to help us move below the surface in this iceberg. It's helping us to understand some of these underlying issues that impact safety. So when we think about road design, we're doing so in the context of this whole transportation system. And think about the safe system or the safe system approach. It's a way of organizing roadway safety action around a set of principles that orient transportation work toward ensuring safety throughout the entire transportation system. So the core principles of the safe system are first, adapting the structure and function of the system to the complexity of human behavior. That's a lot of words to basically say that humans are fallible. Humans make mistakes, and we need to understand that when designing the system, that nobody is going to be the perfect driver, the perfect pedestrian, the perfect bicyclist, that they are going to make mistakes at some point. One other key is managing kinetic energy transfer among road users. So kinetic energy is just the energy that comes from the speed of those on the road as well as the mass, so how big vehicles are. And when you reduce the amount of kinetic energy, you reduce that energy that's transferred in the case of a crash. And by reducing that, you're lowering the risk or likelihood of death or serious injury in the event of a crash. Next principle is to treat road user safety as the foundation of all system interventions. So rather than thinking of mobility and safety as having trade-offs, where when you want to have greater mobility, safety becomes the trade-off, safety is that foundation, that you can have mobility and safety together, but safety would not be a trade-off in order to achieve mobility on the network. And finally, it's fostering the creation of a shared vision and coordinated action. So this is really having stakeholders from multiple sectors or disciplines working together on a common goal, rather than working in their own silos, on their own separated tasks. So in this past year, the US Department of Transportation has adopted a safe system approach. And this US DOT safe systems approach follows similar principles, as we said before, and it sets out a strategy for implementing these principles. The strategy here, a key is that these elements are not to be treated in isolation, but instead they're considered complementary and should be coordinated efforts toward achieving a safe system. So the first one is safer people. And part of that's encouraging safe, responsible behavior from people that use our roads. Key for this module is also to have safer people. You have to create the condition that prioritizes their ability to reach their destination unharmed. So it's not just encouraging safe behavior, but it's also creating the environment where that safe behavior is possible. When it comes to safer roads, that's really all about design. So it's designing the roadway environments to mitigate human mistakes, account for those injury tolerances, really dealing with that kinetic energy management to encourage safer behaviors and facilitate safe travel by the most vulnerable users. Safe vehicles looks at the design of vehicles. That's the technology available in them, but also the design of the vehicle itself. And that expands the availability of systems and features that help prevent crashes and minimize the impact of crashes on both occupants and those outside of the vehicle. Safer speeds. So we'll get into this in just a moment, but speed really is a key part of the safe system and part of designing roadways that will achieve safety. So promoting safer speeds in all roadway environments through a combination of thoughtful, context-appropriate roadway designs, the design that fits the context of where that road is, but also targeted education and outreach campaigns and enforcement, so all together to achieve safer speeds. And then finally, this is after the crash. We recognize that crashes will occur even in a safe system. So this is focusing on post-crash care. So enhancing the survivability of crashes. That's through expedient access to medical or emergency medical care, and also creates a safe working environment for first responders, and helps to prevent any secondary crashes through managing traffic after a crash occurs. So coming back to those principles, like I said before, focus on speed is a key component of the safe system. Speed determines a number of factors that impact these principles. So speed could make the results of a mistake, something we've noted that's a given for humans, more severe. Speed is also in that principle of kinetic energy transfer. So when you have higher speeds, you have more kinetic energy on the network, and in the event of a crash, there's more energy transferred to another road user that increases the likelihood of a death or serious injury. So that's sort of illustrated here on this graphic, which has been shown quite a bit, but still very much illustrates, with just slight increases of speed from 20 to 30 and 30 to 40, you have much lower rates. So you go from at 20 miles per hour, a 10% chance of a fatality when a vehicle hits a pedestrian, up to 40 miles per hour, where it's an 80% chance of a fatality when a vehicle hits a pedestrian. So much of what we'll see in working with road design is going to be an attempt to manage speed, or given this understanding of speed, ensure that where speeds are high, that the likelihood of a collision, especially between a vehicle and people outside of the vehicle, is going to be very low. And this image takes us back, if anyone was in the first module, to the introduction on systems. But I've brought it back here to just, again, note this interconnectedness of so many parts of the system, where we have actions of different stakeholders having sort of a ripple effect that impacts that central goal there of driver yielding to pedestrians in a marked crosswalk. We'll note that design is part of that, and we'll go through a lot of the principles of design in just a bit, but design is part of increasing that driver yielding behavior, but it's not operating on its own. So we recognize that enforcement doesn't operate on its own, education doesn't operate on its own. So none of these solutions are all on their own, but rather they're connected. So all these efforts sort of fit together to help to increase that behavior that we want to see on the network and to increase overall safety. So now sort of getting into more specifics about road design itself. Here are some road design considerations that promote better environments for all users. So obviously we're thinking about promoting walkability and bikeability, promoting bike safety and walking safety in general. But when you think about improving these designs for safety, they're actually going to have an effect on everybody. So the first principle is reducing conflicts. For slowing speeds and changing the geometric design, so introducing medians or shorter crossing distance, it improves safety for all modes because it either eliminates or minimizes the number of conflicts between vehicles and vehicles, or vehicles and those outside of the vehicle. Another key here is considering accessibility. It's not on the list, but when we're thinking through all of this, one of the keys is making sure that all the roads and crossings that we design are going to meet the ADA standards. This is good design that's going to benefit everybody that's trying to use our road network. Another principle is predictability. So this is design that provides clear right-of-way assignments, ensures visibility of all users, and make sure that there's a clear path of travel for all modes. So a predictable road sends that cue to anybody using it as to how that road should be used, speed that should be traveled on that road, everything that they should do on that road, and in reality should actually give those cues to ensure that they're doing so safely. Visibility is going to be one of the keys that we look at in a lot of the countermeasures that we get to. Curb extensions, lighting, pavement markings, any way that's going to improve visibility of all road users, especially those outside of the vehicle. Separation is something that we start to consider as we see speed or volumes increase. So where we see a lot of vehicles or vehicles going at higher speeds, that's when we start to consider greater separation of modes. So you'll see, especially when we're looking at bicycles, how we can kind of create degrees of separation and where those are best utilized. Another principle that design can help to benefit is minimizing delay. So for many pedestrians, this is just reducing delay at crossings. So they don't have to wait so long in order to cross, and that the crossing is relatively quick. So changing crossing distances, working with shorter block lengths. So anything that's going to reduce travel time and minimize delay for road users. And finally, looking at context sensitivity. So, and that was a key in looking at that safer roads principle from USDOT, but that's incorporating the adjacent land use or the natural environment. So understanding where that road is placed, what that road's purpose is, and then designing accordingly so that you don't have a road that's completely mismatched from its surrounding environment. That also leans back to this principle of predictability, because if you have a road that matches the environment, it's going to be more predictable of who goes where vehicles should go, that pedestrians are going to be present, that bicyclists are going to be present. When you design out of context, then it leads to just more confusion, and you have that mismatch of maybe high speeds in an area where you have a lot of pedestrians. So design itself can impact safety through these elements mentioned previously. It also has this added benefit of creating safer, just more inviting spaces for road users outside the vehicle. So as we have an increased perception of safety, you have more pedestrians and bicyclists feeling comfortable. And this may lead to this idea of a safety in numbers effect. So this graph on the right is from a study that shows as you lower pedestrian fatality rates, where you see a higher share of trips made by walking. So the idea really is that potentially as you have more people walking and biking, you have more of that expectation that people are going to be walking and biking from drivers. So they're looking out for people and potential for just safer environments for those outside of the vehicle. But looking more closely at the link between behavior and roadway design, we find that design influences how drivers respond to the roadway. And that driver's response directly impacts safety for other users when there's an interaction or a potential for interaction on the roadway. So roadway design, including the context surrounding the road, and how bike lanes, sidewalks, crosswalks, and intersections are designed, is going to deliver visual cues to the driver as to the expected behavior at that roadway. And these visual cues can be found in the street geometry. So that includes the width of the roads, curves, and the presence of any lane markings or physical barriers on the roadway. That includes landscape, so trees or other plantings on the road's edge sort of serve to create a narrowing effect on the roadway, so that potentially these two drivers going more slowly through a segment that has those landscapes also just serves as a buffer between the road and the sidewalk, so creates that safer, more comfortable environment for those walking. Development is thinking about what type of development is near the roadway. So development is going to send a cue to the driver of where they are. So just thinking about how dense that development is are we looking at a downtown versus a suburban environment or a rural area? That's going to lead to an expectation of pedestrian traffic. It's also just an expectation of the frequency of driveways, where in a downtown or suburban environment, you might have more driveways compared with a more rural area. Intersection design, a lot of it comes down to how they're controlled. So are they going to have a traffic light, a stop sign? What kind of cues are there just to tell the driver whether to stop? What do the turn lanes at an intersection tell the driver? So if you have a right turn lane that has a very wide radius, then you might end up giving that cue to the driver that high speed right turn is okay, meaning that there's less of a likelihood to slow down for pedestrians or look for anybody and just take that higher speed right turn. How the crosswalks and bike lanes are marked through the intersection are also very important, because they give cues to the drivers who might be present and where they might be at the intersection. Any perception of conflict, so that may be intersections, it may be driveway entrances that we mentioned before, crosswalks, whether you're in a dense area. So anything in design that sort of gives the driver an idea that there might be conflicts along the way is a way of telling the driver that, be aware that there's pedestrians or there might be somebody turning left in front of you, but it's any way of just bringing greater attention that they might be interacting with other road users, more frequently in a certain area. And sort of on that flip side is the perception of safety. So rather than perceiving frequent conflict, certain road designs are going to bring this perception of safety. And for the driver, that may actually promote higher speeds. So there could be a trade-off between this perception of conflict, which might cue a driver to slow down and be more aware, to this perception of safety might occur on a wider open road where the driver feels free speeding along. So road design can work to mitigate a number of behaviors and situations to improve safety. I'll be going over several examples of design with a focus on these three major areas of where they work to improve safety. So the first one is speed. And sort of in thinking about this safe system, what's important with speed is we're not simply talking about speeding or breaking the law on the speed limit, but actually controlling speed itself and thinking about speed management at the center of this safe system idea. That's important because, like we said before, managing speed means managing that kinetic energy that's transferred in the event of a crash. Speed management, like we saw before, is directly related to reducing the chance of a death or serious injury. And speed's also related to stopping distance. So you think about the faster a vehicle's traveling, the longer it's going to take to recognize the need to stop, react in a way that starts to slow the vehicle down, and then to actually stop and bring the vehicle to a complete stop. This is especially important when considering crossings, especially mid-block crossings, where the driver has to be able to see someone, register their intention to cross, and be able to stop on time. Design also helps to mitigate conflict. So by conflict, we mean any interaction between road users that could result in a crash. So design that mitigates conflict may encourage separation of modes. And this could be accomplished by keeping vehicles physically separate from other modes. But separation or reducing conflict may also just be separation in time when we're thinking about using signals to indicate who can use the roadway when. And finally, we're looking at this idea of visibility or conspicuity. And road design here is just where we ensure that road users are able to clearly see each other and also be clearly seen by each other. So we're first going to go through a series of example treatments or design elements that promote safety for pedestrians. These are all feature countermeasures from the Federal Highway Administration's Safe Transportation for Every Pedestrian and STEP program. As I go through each, I'll note that each of them helps to meet one of the goals from the previous slide, helping to mitigate issues of speed, reduce conflicts, especially between different modes, and increase visibility for all modes. So we're going to look at some crosswalk visibility enhancements, the pedestrian refuge island, the raised crosswalk, road diets, and then several different treatments on signals or different types of signals that help increase pedestrian safety. So we'll start with something very simple, but also very necessary, and that's just the need to make the crossing itself visible. So in this image here, you can see on the left side, going bottom to top on the roadway, are the sort of older two-line marking. And that two-line marking is often difficult to see for a driver, especially if there's absence of any other signage or warnings saying that the crosswalk is approaching. Another issue with the two-line warning is, given any lack of maintenance, that crosswalk suddenly becomes even less visible. Once those lines start to wear down, there's nothing in the crosswalk itself to be seen. So we're talking about making the crosswalk itself visible, we're looking at these high visibility crosswalks. So that's what's going across the road on the sort of right hand side of the photo. And the high visibility crosswalk are wide bars. They're painted in the direction of travel that mark the crossing location. They're more visible to drivers on the approach to the crossing, so they make that crosswalk location just more obvious to anybody approaching. In addition, there is some idea that, well, because they go through the entire crosswalk and because they go in the direction of travel, there's a little less maintenance is required, or it takes a little bit more time before they start to wear down. So they're going to remain visible despite vehicles driving over them. So as we start to look at these remaining countermeasures, this is sort of the baseline that we start with. So it's recommended that they're paired with one of these improved high visibility crosswalks. Our next one are these advanced lines. They're what are sometimes called shark teeth. So if you look at the image, they're that line of triangle-shaped markings that are placed, in advance of the crosswalk. So they're employed in front of crosswalks, and they indicate the driver's need to yield to pedestrians and to yield behind that line. They work to enhance visibility in situations where there's the risk of what's known as the multiple threat crash. This is a type of crash that occurs on multi-lane crossings where, like you see in the image, on that sort of left-hand side, you have one vehicle that's stopped behind the line. If another vehicle comes along in that left lane and stops behind the yield line, they're still going to have full view of the pedestrian that's trying to cross. The pedestrian's going to have a better view of that far lane, so they see any oncoming traffic. Were you not to have those advanced yield lines and the cars are stopping a little closer to the crosswalk, then that visibility for the pedestrian of that other lane is going to be obscured. So they don't know if it's safe to cross. And a car in that left lane is not going to necessarily see the pedestrian and may just go right through the crosswalk instead of stopping ahead of time. So this just indicates that point to stop or yield that allows that pedestrian to view any vehicles in other lanes, increasing visibility on both sides. Next countermeasure are curb extensions. So these help to deliver a better level of visibility for the pedestrian and the driver. Curb extensions are also known as curb outs and bulb outs. They extend the waiting area for the pedestrian out into the roadway. Oftentimes they involve just building out the sidewalk and the curb, complete with a curb ramp down to street level, out into that intersection or into the roadway. That's sort of the example you see on the left. On the right, you see an example of where they could also be accomplished using paint, bollards. In this example, there's some planters placed there, but it also just serves to push that waiting area out into the roadway. So in a mid-block crossing, like we see in actually both of these examples, the curb extension, it makes the pedestrian intending to cross more visible to oncoming vehicles. And at an intersection, the curb extension places pedestrians crossing where a vehicle is turning right more into the line of sight of a vehicle. So that makes the pedestrian more visible before the driver starts to make that right turn into the pedestrian's path. The curb extensions also reduce crossing distance for pedestrians. So that's going to lead to less exposure to vehicles when a pedestrian is crossing, and also just leads to faster crossing times. That also just helps to benefit pedestrians of all abilities. So it's just a shorter crossing distance to get across the roadway. So it's noted here that this countermeasure is set up to enhance visibility, but it's also something that can impact vehicle speeds near crossings. At a mid-block crossing, curb extensions narrow the roadway, which might help to slow vehicle travel as they approach and go through the crossing. At intersections, curb extensions reduce the curb radius. So as cars are going to turn right, they're going to have to slow down more before turning through that crosswalk that's going in the same direction. Something that kind of goes along with curb extensions, but also could be used on its own are parking restrictions. These are sometimes referred to as daylighting. So a common issue at intersections or mid-block crossings where you have parallel parking is that the pedestrian attempting to cross can't see any oncoming vehicles because there's a vehicle parked right at that crossing or right at that intersection. And at the same time, as the pedestrian starts to move out into the roadway behind that parked vehicle so they can see any oncoming traffic, they also aren't visible to any drivers coming through the crosswalk until they come out from behind that parked car. So parking restrictions or daylighting restricts parking in that parking spot just before the crossing. So where a curb extension is actually built up with a curb and sidewalk coming out, this could be accomplished by just building that curb extension even wider to fill some or all of that parking space just before the crosswalk. In other cases, it may be just done so with pavement markings or signage or bollards. In some places, they put up bollards and then actually use that former parking space to put a bike rack for bike parking. So in any of those cases, the pedestrian can enter that crosswalk with a better view of traffic and in full view of oncoming drivers. And parking restrictions, just like curb extensions, they can effectively reduce crossing distance as well, and that's going to reduce pedestrian exposure to vehicles. So in-street signage that you see here, this is sometimes referred to as the gateway treatment, but involves placing this yield to pedestrian signs directly in the pavement. They're usually placed in the yellow line just on the edge of the marked crosswalk. And they help to make the crossing more visible to drivers. So that idea is to make sure the drivers see the sign and know that they're supposed to yield at that crosswalk. They also can create a sense of narrowing lanes as the driver approaches the crosswalk, which can help to encourage more yielding to pedestrians. That feeling of lane narrowing can be made more noticeable if an in-street sign is combined with curb extensions. In some cases, the in-street signs placed in the middle, but then there's also in-street signs placed on the outside lines of the lanes too, just to increase that sense of narrowing as you go into a place where there will be pedestrians. So the next one is the pedestrian refuge island, and these are built into the middle of roadways where pedestrians will have multiple lanes to cross. They're generally built with curbs raised on either approach side, so on the sort of top and bottom of the crosswalk, and would have signage usually in the middle to indicate that there is a crossing location there. When you have longer crossings where a pedestrian maybe has to cross 2 lanes and then 2 lanes, so a 4-lane road or wider, they allow the pedestrian to cross one side of the road at a time. So that limits exposure to traffic and allows people crossing to focus on one direction of vehicle travel at a time. Pedestrians wait in the island, and in doing so, they're more visible to drivers approaching the crossing because they're in the middle of the road. And then that crossing itself also becomes more visible to drivers with that increased signage with the curb coming up. And just like in-street signage and curb extensions, they can create that lane narrowing effect that may slow vehicle speeds and also encourage yielding. And one consideration with the pedestrian refuge island is ensuring that accessibility is important. So as you can kind of see in that picture, when you have the curb ramp come down from the sidewalk or that curb extension on the side, then the refuge is built on either side of the crosswalk, but the crosswalk remains at the same grade the entire way. So any pedestrians with disabilities or using assisted devices aren't going to have to go up and down onto a curb or up and down too much, that the crossing is made better for anybody with accessibility issues. So a raised crosswalk is another treatment, and it's effectively a crosswalk that's on a speed hump. They would include signage indicating that a driver should slow on the approach to the crosswalk, that there will be a raised portion of the roadway. Um, they work as a obviously as a control for speed, just like many speed humps. So the drivers have to slow down prior to and driving over the crossing. But they also work to improve visibility of pedestrians because they don't require pedestrians to go down and then back up again. Instead, pedestrians will cross at the same height as the sidewalk on either side. So at the start and through the crossing, pedestrians would be more visible to drivers throughout that entire crossing. They also can help to improve accessibility because, like we mentioned before, they're not going to require pedestrians to go down to street level and back up again. So, again, anybody with an assistive device, a wheelchair, or somebody pushing a stroller, it's a much easier crossing because it just stays at that sidewalk grade the entire way. Road diets, these are sometimes referred to as road conversions, lane reallocations. They're any work that reworks the roadway to reduce lanes and generally allow more space for multiple modes. Some of the common road diets are reducing from 4 travel lanes, there's 4 vehicle lanes, to 2 vehicle lanes with a center turn lane. And that often comes with the addition of bike lanes. Um, and they can be quite simple. So at the simplest level, they're just accomplished by restriping the roadway to change the lane configuration. Um, where a pedestrian may have had to cross 4 or more lanes of vehicle traffic, the road diet reduces that crossing distance and helps reduce exposure to vehicle. If the reduction in lanes is accompanied by a reduction in lane width, that might start to send that cue to drivers as well that they reduce speed. So not only does the pedestrian have a shorter crossing and less exposure to vehicles, but there's less exposure to vehicles traveling at higher speeds. And road diets a lot of times are part of larger redesigns where they're used in combination with a number of the previous countermeasures. So road diets can go in with curb extensions, pedestrian refuge islands, any parking restrictions, anything that's going to improve visibility for pedestrians, further help to reduce speeds, and just generally make a more comfortable environment for pedestrians and bicyclists. So the next few countermeasures we'll go through for pedestrians all deal with signals. And this first one is just a change to the actual walk signal and your sort of standard traffic signal itself. And it's known as the leading pedestrian interval, or LPI. So with an LPI, the pedestrians are given a walk signal for generally around 3 to 7 seconds, while vehicles going in the same direction still have a red light. So after about that 3 to 7 seconds of a walk signal, the vehicles going in that direction would get a green light in order to then go straight through the intersection. And the idea behind this is to give pedestrians a head start to enter that crosswalk before vehicles begin turning right or left, where there's an allowed left through the crosswalk. It helps to ideally reduce conflicts because it gives pedestrian a chance to either fully cross in the case of a shorter crosswalk, or be in that crosswalk so they're in full view of drivers that are going to be turning right, and that helps to increase the likelihood of a vehicle turning right, yielding to pedestrians who are going to be in the crosswalk. One recommendation for the LPI is that it's paired with a restriction in right turns on red. If you're still allowing a right turn on red, then vehicles are still allowed to enter the intersection and make that right turn when pedestrians are given that early walk signal. So even though they have that early walk signal, drivers may still be attempting to turn during that early walk phase. drivers also may still be looking for gaps in traffic rather than looking at pedestrians or realizing that they have that walk signal while they have a red light and shouldn't be turning right. So the next two are sort of different types of signals aimed at mid-block crossings, but set up to allow for better pedestrian or crossing environments for pedestrians. So this first one is the pedestrian hybrid beacon. It's called also known as a PHB, sometimes called a hawk signal. These are pedestrian activated signals, and they're recommended for use on unsignalized mid-block crossings, especially where vehicle speeds are high or you might have higher vehicle volumes. They go through a signal phase once the pedestrian activates. So if you can kind of see the graphic there, when they're off, all signals are completely turned off. When the pedestrian hits the button to cross, you start to have the flashing yellow light. And that just alerts drivers to slow down and that the crossing is about to turn red. So it goes through a flashing yellow phase, a steady yellow where it just stays yellow, and then after that turns to where both those top red lights are on steady. So when the red lights are on, that means the walk interval has started. So the pedestrians have the walk signal and they can go across. Then the red lights begin alternating, flashing the left and right light. And that means that the walk signal is almost finished, but there may still be people entering the crosswalk. There may still be people in the crosswalk finishing the crossing. So the cars that have stopped are allowed to go through. Any cars approaching would need to stop, look for pedestrians, and then continue through. And then the light goes off and the pedestrian don't walk sign comes on. So vehicles can travel through and the pedestrian would have to activate it again to restart the cycle. One thing to note about pedestrian hybrid beacons, they've been around for a while, but they're still novel in a lot of communities. So sometimes installation may require some kind of outreach to inform drivers of how they operate and what the expected behavior is at the pedestrian hybrid beacon. So going down to, two-lane or multiple lane locations, still looking at mid-block crossings, but areas with maybe lower speeds and less volume than what you would have at the pedestrian hybrid beacon. We have the rectangular rapid flashing beacon, also known as RRFBs. So these are sets of flashing lights. They are installed at either end of the crosswalk, so they don't go overhead, but just at the ends. Again, they're pedestrian activated, so the pedestrian hits the button, and then the lights on the crosswalk sign start flashing. When the lights are flashing, that indicates that the pedestrian is likely to be in the crosswalk and crossing. So vehicles approaching would need to either slow down or come to a complete stop, let the pedestrian cross, and then continue on through. They can often be combined with other treatments like high visibility crosswalks, putting in advanced yield lines, curb extensions, and refuge islands, and maybe in-street signage, or in some cases where you have the pedestrian island, there's another sign in the middle of the road that has the flashing beacon for vehicles to see. Okay, now that we've gone through all the pedestrian countermeasures and we've hit just about an hour, we'll take a break for about 10 minutes. So it's 10:55. If we can come back at 11:05, and we'll continue on with some countermeasures for bicyclists. And again, if you do have questions, feel free to place them in the chat, but I'll see you back here in about 10 minutes. Back. Recording in progress. So great. Well, thanks to we had a couple questions in the chat and sent some links out. We had another question before the break. Someone's asking more specifically about how to get sidewalks in your community. And we can post up in the chat So there's the residence guide from the Federal Highway Administration. That's the residence guide for creating safe walking and bike and green environments. But there's some sections in there about just working with your local community to bring that about. You know, a lot of that is going to depend on your town, and then depend on what road you actually live on, and who has the responsibility for it, whether that's a town road or a state-owned road. But that residence guide may have some tips there. But you know, definitely encouraged to talk to your town staff and figure out, you know, what it might take. Do they have a program where you can petition for such a thing, or do some, you know, audits of the safety or road users in that area, and try to bring that about. But yeah, like I said, starting with town staff is good, or even elected leaders to sort of help to encourage that change. Okay, so I'm going to continue on, and now switch over from pedestrian safety to looking at just a few examples for bicyclist safety. And you know, same principles apply, where we're looking at speed, we're looking at conflict, and so what we're trying to sort of mitigate here is one, just that interaction between vehicles and bicyclists. So more so than pedestrians, vehicles and bicyclists often end up using the same roadway. So it's trying to figure out how we can allocate space, and where and when we should allocate the right type of separation to deal with that interaction between vehicles and those on bicycles. And then a special case that relates to bicyclist safety, it also does relate to pedestrian safety. It's looking at crossings at any trail or greenway locations. So these are special cases because a lot of times the trail, greenway, or path maybe hasn't been running parallel to the road, or hasn't been near the road. So all of a sudden there's just an intersection with a trail and a roadway. So looking at just some examples of how to work with those locations. So when we think about bike lanes on the street, what we think about is our sort of basic bike lane, and that's the separated bike lane. And that's anytime we use painted lines to delineate the separation between bicyclists and any other vehicles. And that includes that pavement marking to indicate that the line is for a bicycle. So the simplest one is what's shown in the picture, and that's just a stripe painted down the line with that bicycle insignia in the lane to say this is where bikes go. Vehicles go on the other side. In some cases, places would use what's called a buffered bike lane. It's still going to be a painted line, but the idea is to just try to create a bit more of that separation between bicyclists and the vehicle lanes. So rather than having that single stripe down on the side of the bike lane, usually it involves two stripes, you know, a foot, 2 feet, you know, whatever is possible apart, and usually some sort of kind of hash marks on the inside, just to create that wider buffer between the bicyclists and the cars. You know, that helps create that extra separation, because even when you have a bike lane, sometimes it's still difficult for vehicles to keep that required 3 feet of space between a bicyclist and the vehicle, even though there is a separated lane. So having that buffered lane just adds that extra spatial separation between modes. And they do provide separation. However, at the end of the day, it's just painted lines. And you know, if we're dealing with areas of high speed, areas of, you know, extra vehicle traffic, they're not going to block vehicles from entering the bike lane. So you may have places where vehicles park in the bike lane, where people use the bike lane as a sort of repurpose it as a passing lane for other cars trying to turn left. So when you just have paint, you still don't have that physical separation that keeps vehicles from encroaching the space for bicyclists. So when it comes to that next level of separation, we look at actual physically separated bike lanes. These are often referred to as protected bike lanes or cycle tracks, but they provide that physical separation between bikes and vehicles to keep vehicles from actually going into the bike lane. A lot of time these involve curbs along the lane. They might involve just using bollards or some other means of creating that physical separation. We've seen places that use planters or actual use trees or some kind of landscaping to create that separation. In other cases, on-street parking might actually serve as that separation between vehicle travel lanes and bike lanes, where instead of having the parking at the curb, it's moved in on the other side of the bike lane so that there's a separation between vehicles and the bike lane. That also adds an extra layer of protection for bicyclists because any driver that's parking in the parallel parking lane, rather than opening a door into the bike lane to get out of the vehicle, they're opening the door into the vehicle lane. So you reduce the chance of a driver opening the door into a bicyclist and doing a dooring, which can prove very dangerous for cyclists. So in addition to creating safety by reducing interactions between bicyclists and motor vehicles, it also just provides that greater level of comfort for the rider, which encourages possibly more people to ride. And then again, that safety in numbers effect that we discussed previously. So one key piece of concern when it comes to bicyclist safety is what to do at the intersection. So intersections will present risks of different types of crashes for bicyclists. One really of note is what's called the right hook crash. So that's where you have a bike lane that maybe goes up to the intersection or even through the intersection. And then you also have vehicles turning right at the intersection. So a right hooker crash would occur when you have a bicyclist attempting to go straight through the intersection and a driver who does not see that bicyclist coming around on the right side of the vehicle and then attempts to turn right and ends up going into the bicyclist. So other issues that exist with intersections may occur where oftentimes the bike lane just drops, so the bicyclists have to merge into vehicular traffic to get through the intersection and then potentially back into a bike lane at the other end of the intersection. That can also just increase conflict where that occurs with a right turn lane, especially a right turn lane that doesn't require vehicles or drivers to slow down to make that right turn. So you have vehicles coming over to the right turn lane, you have bicyclists moving left because they have to merge into that lane and then suddenly share that lane for just a little bit. So there's a lot of conflict that can happen at the intersection. So some of the solutions are similar to above that include curb extensions, which end up slowing the turning vehicles. So just like with pedestrians, when the vehicle has to kind of take that sharper turn to turn right, rather than being able to kind of go at speed and not have to sort of see who's in the intersection when they're turning, the curb extension kind of forces them to see not only the pedestrian, but also any bicyclists that are trying to go straight through the intersection. A lot of efforts also include providing any kind of extra space that's just going to increase the visibility of the bicyclists at the intersection. And they also allow bikes to enter the intersection earlier than vehicles, so they're visible to anybody driving through. These include bike boxes, which are on that picture on the left. And that's just where bikes have that designated space. Usually it's painted green and it's in front of the vehicle stop line, so that the bikes can kind of come up to the front and they're visible to anybody driving through. Another example is this protected intersection, which is, involves a lot more construction, but it's there on the right side. And that's sort of taking that curb extension even farther into the intersection, so that you have a cutout to allow the bike lane to go through the curb extension. The bikes end up having a much shorter crossing space, so they're not exposed to traffic in the intersection for so long. They also have that green space, you can see there, that serves as sort of that waiting space. So any vehicle turning right is going to see bicyclists waiting to go straight across the intersection. Bicyclists are going to have that chance to go right first, so they can kind of clear the intersection before vehicles start turning right. They'll clear the intersection faster because they're out a lot more in front, and also just visible, so that any drivers can see that there's bicyclists intending to go through the intersection. The special case that many communities here have encounters with is what to do when a trail or greenway intersects with a road. This creates, like I said before, a different scenario where the pedestrian, bicycle traffic and vehicle traffic have been separate and possibly traveling at a higher speed, each of them, and must interact in some way. A lot of times these end up coming out at mid-block locations, and they lack stop control, so they don't have either traffic lights or stop signs. So sort of the key here is just that, a lot of the best practices for intersections or for mid-block crossings are going to apply to trail or path crossings as well. So that's, minimizing the trail user's exposure to traffic. So, that can be achieved through intersection or mid-block crossing medians, any other crossing treatments. Where possible, it's ideal to have that path go across perpendicular. That improves visibility, but it also shortens that crossing distance, so any trail user can get across the roadway quicker, and not be exposed to traffic for so long. Any way to reduce speeds before the trail crossing is also recommended. This is reducing speed for both path users and road users. That helps minimize conflicts, and it gives everybody approaching the crossing just that additional time to recognize that there is a crossing, and to know where the right of way is and who should yield to whom at the crossing. And noting that right of way should be clearly indicated for pedestrian and bicyclists as well as vehicles, so it's clear who yields to whom when it comes to the trail crossing. One consideration that FHWA notes are what to do about bollards. So a lot of times bollards end up being sort of the go-to for managing trail access. They are generally considered not as effective, and it's basically because, if someone's determined to get on a trail, someone can go around them. They sit on the trailway, but there may also be just grass or something around it, so a vehicle could go around. So if there's no other option, they can be used, but there are just some considerations when using bollards or any gates or fences, or other kinds of barriers at the entrance to a trail. Number one is just making sure that they don't restrict any access for people with disabilities. So they have to be easy to go around. And this includes just ensuring that they allow passage for anything wide. So that's considering wheelchairs, that's considering adult tricycles, a bicycle towing a trailer, a tandem bicycle, strollers. So if bollards are placed in such a way to restrict that kind of access, you're restricting access to those who can use your trail. Ensure that they're visible, especially in the low light conditions that some trails are in, so that they aren't a crash hazard, that they're visible for any vehicles coming through. So that's ensuring not just that they're they're visible in the light, but that they're visible from enough distance. So if a vehicle or a trail user is coming up on a bollard, they need to be visible enough to where they can adjust their speed and either go around or through whatever bollards are placed. So thinking about crossing types, so we're looking at whether to use controlled or uncontrolled crossings. So when we think about controlled, these are yield and stop controlled crossings for both path users. That's the pedestrian and bicycles and the road traffic. And that really takes some consideration of traffic traffic on the path. So how many pedestrian bicycles using the path, and traffic on the roadway. So what the vehicle volumes are. Sometimes it's more practical to use stop controls on the road traffic. But in some cases where there's just a greater volume or faster flow of vehicle traffic at crossings, sometimes it's better to place those controls on the path users. Or as we'll show on the following slides, just use some additional measures to control vehicle traffic through the crosswalk. At any uncontrolled crossing, it's just essential to make sure the crosswalk is visible. Like we said before, high visibility crosswalks are sort of the key, the base level. Unless the consideration here is if pedestrian counts are especially low, it may not be necessary, but really considering making sure that the crosswalk is visible. And if traffic speeds exceed 40 miles per hour, if we have high volume of traffic, it's also recommended to try to incorporate some speed reductions, especially if it's not a controlled crossing. So that's using traffic calming devices or something in the roadway that's going to have vehicles slow down before they get to that crossing. Another consideration is what to do about grade separation. So in general, if you're trying to separate grade, that's creating a pedestrian bicycle overpass or creating a tunnel. Those are your more expensive options. They're not necessarily as practical. They're also going to involve less connectivity between the trail and the roadway. So they're really more ideal if you're dealing with really high traffic, really high speed areas where you don't necessarily need that connectivity. Some issues with them other than just the expense of installing them are if there's another easier, better option to cross the roadway, pedestrians are going to use it rather than using the tunnel or a overpass. Overpasses, just tend to be a hassle. They involve a little bit more effort, and if there seems like there's an easier crosswalk, it's going to get used. Tunnels, if there's another option, especially when tunnels are dark or you don't necessarily see the light as easily through the tunnel. They don't necessarily feel as safe or secure for many pedestrians, so they might avoid using them. Sorry about that. Okay, I'm back. Sorry about that. I am recovering from being ill last week, so this is a lot of talking for coming back from that. Let me get my video back here. Well, there it is. Okay, so just a couple more notes on trail crossings. Because they often intersect mid-block, some of the signals mentioned previously may be effective for both pedestrian and bicycle crossing. And these are going to include the RFB and that pedestrian highway beacon. And just as we mentioned before, specifically about pedestrian crossing, but here, it would be, useful for bike crossing as well. It's, thinking about the characteristics of the roadway. So how many lanes you're crossing, what are the speeds, and what are the traffic volumes that you're dealing with, to decide which of these might be necessary when it comes to a trail crossing. Another thing to note, that is really important, especially if you have a transit system in your town, is what to do for pedestrian safety for transit users. So it's often noted that transit users are all pedestrians or bicyclists at some point in their journey. So it's really important to ensure the safety of transit users on their way to and from a bus stop. And that's necessary to understand what accommodations are in place for pedestrians near the stop. So, if you're observing, pedestrians crossing near a bus stop and not necessarily in a crosswalk, or vehicles not yielding to pedestrians, or just looking at the area around a transit stop, there's some questions to really ask when it comes to design, and whether that design of the roadway has really taken the transit users and their role as pedestrians into account in ensuring that safer system. So, at the base level is just looking at, other sidewalks leading up to the stop, or do the riders need to walk in the road to get to their transit stop? You might see a lot of bus stops that have what we call desire lines, or the goat paths along in the dirt going up to the bus stop, and that indicates that people are walking here and that they don't have a sidewalk, and they may be able to walk on the side of the road, but if it's raining, that's mud, and then they have to be in the road, and that's a dangerous situation. Looking at the bus stops themselves, another question is, are they accessible, or will a wheelchair user have to actually get into the roadway in order to get onto the bus? Again, creating a dangerous situation for anybody, or restricting access to necessary transit for people that use wheelchairs. At the bus stops themselves, are crosswalks at the bus stop, or at least pretty close to them? And then, are there any safety measures in place around that crosswalk to make sure that transit users are able to cross safely at that location? At some point in a round trip journey, bus riders are going to have to cross to or from their stop in order to get home. So when you see a transit stop, but the crosswalk is a quarter mile away, or sometimes even farther, that's if they're doing a transfer, or having to get to that bus stop on the other side of the road, that's where you might start to see pedestrians doing what we consider an unsafe behavior, but it's a behavior that is completely understandable when it's 95 degrees outside and they just need to get on their next bus to get home, or that's what feels safe at the time, because that's all that's available. So many of the previous countermeasures apply here. Just what's important to note is whether the design of the roadway near the transit stop has been considered to ensure the safety of riders by ensuring that there are safe crossing opportunities. So finally, one thing that doesn't come up immediately when we discuss road design is thinking about maintenance. So most of what we've encountered so far today are countermeasures or enhancements to the roadway. And these are just ways that we can add to or change the road to make it safer. Maintenance then is often overlooked as a key component for safety. And then really going back to a lot of what we were talking about at the beginning, that speaks to some of the inequities that we addressed at the beginning, where situations speak to some of these underlying issues, like neglect in some communities, and that's going to create these unsafe environments. So here's a few considerations for safety that may be handled by good maintenance. So you've got bike lanes, which is great. So you've got a nice safe spot for bicycles to ride, but for bicyclists, you still need that clean, smooth path to avoid any hazards that might damage the bike or make it unsafe to ride in a bike lane. So even if that lane's provided, a bicyclist may find it full of debris, or the paving is in a condition um, that they feel safer, or that their only option is to ride in the vehicle travel lane. You know, you have gravel driveways that come out into the bike lane, and as cars come out, that gravel just keeps filling the bike lane. So you've either got a safety hazard where it's easy to crash a bike, or to avoid such a hazard, they're creating that hazard of riding in what could potentially be higher speed vehicle travel lanes. Or in some cases where a bicyclist doesn't feel safe in the bike lane, um, they end up riding on the sidewalk where it's not prevented by law, and maybe gets in the way of pedestrians trying to walk. So efforts to maintain the bike lane, it would encourage use of the bike lane and continue to ensure that safe separation of modes. This may be more complicated where there are those physically separated bike lanes, but maintenance there is still just an essential part to ensure safety. And we're looking at sidewalks. Sidewalk disrepair can lead to unsafe conditions in general. And it also, just like bicyclists, may cause sidewalk users to travel in more unsafe locations just because of their limited accessibility. At the basic level, an unmaintained sidewalk can be a tripping hazard. So raised, broken sections interfere with walking. A tripping hazard would be dangerous because it causes a fall where a pedestrian is injured by hitting the sidewalk, or even more dangerous, may potentially cause a fall where the pedestrian falls into the roadway. And for those using assisted devices, so those using wheelchair or anybody pushing a stroller, sidewalk disrepair is not only a safety hazard in itself, but it makes the sidewalk inaccessible, where they can't actually navigate through that section of sidewalk. So these people may be forced into that dangerous situation of operating a wheelchair, pushing a stroller in the vehicle travel lanes, if that's the only way that they can actually get through that section that's unmaintained. So now I want to open it up for some discussion. So would love to hear from any of you here. So we're going to open up the chat, or feel free to just unmute yourself and talk, or raise your hand. We've got several people sort of monitoring, but really want to see if anyone has examples where you've worked with your city, county, state on a design solution for a safety problem. Places where you've seen safety concerns, risks, whether it's crashes already, potentials for crashes, higher speeds. So you recognize that there actually needs to be a design solution for this safety problem. Let us know what it was. Who did you work with in order to reach that solution? Was there a way that you identified the problem and could understand that it really was a design change that was needed? And anything you might have learned from the process. So open it up if anyone wants to either chime in, come off mic, or raise your hand and I'll call on you, or add something to the chat. I know we're approaching lunchtime. People might be quieter. Well, in that case, we will press on and keep going towards the end here, and maybe end up a few minutes early. So, so just a couple things to sort of leave with here. We're sort of going from these little countermeasures and things to thinking more about policy. So, much of what I've covered really could still be a reaction to a crash. It's still that top level of the iceberg we saw earlier. So we want to think about how this all comes together, to move further down that iceberg into really how the system is designed. And I wanted to just highlight one policy here. Obviously, there's other policies that include safety as a foundation, but this is one that has some focus on safety. And it's also a chance to kind of undo some of that legacy of design that we talked about, or decisions that may have created these unsafe environments in the first place. So complete streets, it involves a culmination of many of the treatments we saw previously. It's a policy of designing roadways to allow safe, comfortable travel for all modes. And this means prioritizing lower speeds throughout the network to allow safer travels for those outside of vehicles. It also means frequent safe crossings so pedestrians do not have to cross wide, high-speed streets to get to their destinations. So pictured here is an example of what we might consider a complete street. If you do look at the picture, you can see there's wide sidewalks on either side of the road, so not just sort of your bare minimum sidewalks. So there's plenty of space for pedestrians to walk on each side of the road. This, I don't know the history of this street, but it almost looks like a street that maybe used to be wider, but it's been road dieted down to 2 lanes in either direction, with a clearly marked bike lane on either side of the vehicle travel lanes and parking lanes. And then you can see at the bottom of that photo, you've got a curb extension coming out. So it comes out more into the roadway, but not over the bike lane. So the bikes can still travel through, but pedestrians are out there with a shorter crossing distance. And you can kind of tell just up in the distance that there's another crossing not too far away. So that idea of having frequent safe crossings is really important here in a complete street, so that pedestrians don't have to walk way far out of their way, or potentially just decide to cross an unmarked or at any location to cross the street, but they have those frequent opportunities. Creates that safer environment for pedestrians, so they know, I can cross at any number of places here. But it also creates that increased expectation for anyone driving through on a complete street that there are going to be pedestrians crossing. They're going to be crossing at any number of places. So I should be on the lookout for that, rather than just speeding through as if it's some kind of highway. So just a quick sort of highlight of North Carolina's complete streets policy. The benefits the state claims for it is making it easier for travelers to get where they need to go. It encourages the use of forms of transportation outside the vehicle. Helps to build more sustainable communities, and a lot of it's about connecting neighborhoods, making sure streets are more connected, and connecting transit systems to towns and cities. And at the end, that foundation again is improving safety for all road users, for pedestrians, cyclists, and motorists. So complete streets comes into consideration with any plan changes to the road. So if a town has bicycle plans, pedestrian plans, or transit plans, complete street means it will consider any of those plan changes anytime there's work being done. And there's more information about the complete streets policy at this link here, completestreetsnc.org. And then finally, just a reference here. I'm not going to actually click through and show the entire thing because it is very large. But I think it's a good reference to just look at for what the NCDOT uses for decision making when it comes to pedestrian crossing. Just again, when you're trying to improve crossing, work with the DOT on DOT roads, it's good to have more information and be sort of armed with this. So This is a flow chart of all that's considered when evaluating crossing locations and starting to determine which treatments are applicable. But it's good just to see what factors are included in that process. So you know kind of potentially what data needs to be gathered or what information you need to bring to the table when you start asking for some different crossing treatments. Finally, here's a list of resources that informed a lot of this presentation. So many of these are already in the link or are in the in the chat. This is also, the slides will be shared with the recording, so you'll have access to all these resources. And a final note on upcoming workshops. So again, we have module 4 on crash data investigation and reporting in August. We have module 5 on communications around pedestrian bicycle safety in September. So I want to thank everyone for attending this workshop today. We hope that if any of the next workshops are of interest to you, we see you there. And just a reminder that these sessions are all recorded, including this one, and they'll be posted to YouTube. You'll get an email when they're posted, and do feel free to share this and any of the other recordings on that YouTube channel with anybody who might be interested. And again, for any of these upcoming workshops, all the partner agencies should have received calendar invites for each of them. If not, feel free to reach out and we will get that to you. Otherwise, thanks again for attending, and we hope to see you at the next training. Here is my information, as well as Sarah O'Brien and Kristen Blank, who've been answering the chat. Do feel free to reach out with any questions you have, and thanks again for joining us. We're a little bit early, so if anybody does have questions or wants to stay on, feel free to put them in the chat or just talk. Otherwise, we will sign off in a couple minutes. Okay, I'm not seeing anybody jump at the bit to write questions in the chat, so we will go ahead and end the presentation. Thanks again for attending. You've got all our contact information, so if questions do arise, do feel free to reach out, and enjoy the rest of your Wednesdays.